Today we're going to talk about section 8.5, which is properties of determinants. We're going to talk about 5 different properties of determinants that will help you in figuring them out. I want you to know these properties, but realistically, the best thing is if you know how to figure out a determinant, then you're okay. So you need to know these properties because they'll help you and there's something to keep in the back of your mind, but it's not as huge of a deal. So first, I want to point something out. You know that when you do expansion by minors to find your determinant, that you are going to want zeros and as many rows in your row that you choose. So if you have an example, if you have a problem like this one here, see you have a 0 here or you have a 0 here, and you could choose either this row or this column here to figure out the determinant, because if you did your expansion by minors, you'd have one of them that was a 0, and that would make it really easy. Well, the other thing you can do is use your Gaussian elimination techniques and you combine rows so that you end up with lots of zeros. So do you see how we multiply this row here, multiply row 1 by 3 and add it to row 2, and we got all zeros. Or we got a 0 in the first one, and then multiply row 1 by 2 and add it to row 3, and we got a 0 here in the second part. So now we have a column that's all 1s and 0s. So then when we go down here to get figure out our other determinant, they went ahead and found this one, so they have 2 zeros here, and now we've got another column for this determinant. So the point is that if you can rearrange your matrix using Gaussian elimination techniques so that you have a lot of zeros, then it makes it really easy because you've got your cofactors are zeros. So we've got this cofactor here that we have to multiply, and then we've got 0, 0, 0 because we expanded along this column. And then to find this 3 by 3 one, we can expand along this column, and again, we've got our first cofactor and then 0 and 0, and that makes it easier to figure out the determinant. Now, elementary row options can make the computations easier. This one makes it easier by using Gaussian elimination techniques where we add multiples. So there's lots of other ways that we can look at this. So let's look at these properties and make sure that we know the properties, but more importantly that we know how to do determinants, because for the most part I want you, a 2 by 2 absolutely you should be able to do by hand. A 3 by 3 of course you should also be able to do either by expansion by minors or by multiplying the diagonals. But we get much bigger than a 3 by 3 and we're going to use the technology available to us. So we're just going to practice so we can make sure we know what's going on, because if you don't know what's going on, your calculator is going to lie to you and you're not going to know that. You're not going to even realize it. So the first property we're going to talk about, if you have the same matrix except rows are interchanged, then the determinant of the first matrix, we'll call it A, is the opposite sign of the determinant of the second matrix. For example, if we have this matrix here, and we're going to use 2 by 2s because, like I said, you need to absolutely know how to do a 2 by 2, but I'm not concerned that you can do a 4 by 4 or 5 by 5. That's just more than what we need to deal with. So if we have this as A, then our determinant, remember, multiply the diagonals and subtract, so 30 minus negative 21, so that's 51. And for B, we've got the rows are switched on this one. So they're the same matrix except the rows are switched. So the determinant of B is negative 21 minus 30, which is negative 51. So you can see that they're the same number but different signs. So if you have the same matrix and the rows are interchanged, if you've calculated one of them, you don't have to calculate the other one because you know it should be the same except for a change of sign. All right, the second property that you need to know is if you have the same matrix except that one row is multiplied by a scalar, remember a scalar is just a number, then the determinant of the first matrix is equal to that scalar times the determinant of the second. Or other way around. The determinant of the second is equal to, sorry, you guys can probably tell it's early in the morning. The determinant of the second is the scalar times the determinant of the first matrix. So for example, if we have A is -1, 9, 7, -4, and B is -1, 9, and then 21, -12. So this is just the row from the second one times 3. See, 7 times 3, -4 times 3. So the determinant of A is 4 minus 63, or -59. And the determinant of B is 12 minus 189, which is -177. This number is -59 times 3. So the determinant of B equals 3 times the determinant of A, because we multiplied times 3 to get that new row. So if you have a matrix that's the same except one of the rows is just a multiple, then once you've calculated the simpler determinant, you just multiply it times that scalar and you'll get the determinant of the other one. Now, the third property that you need to know is if the second matrix is gotten by adding a multiple of one row, of the first to another, then the determinants are equal. And that's that example we were just looking at from the book. If we have two determinants, or two matrices, and we're looking for their determinants. If we look at this one right here is, if we take the 3 times row 1 plus row 2 of matrix A, that's how we get this one. 24 plus 2 is 26, 11, or 33 minus 3 is 30. So this is kind of those Gaussian elimination techniques that we were talking about. So if you notice, the determinant of A is -24 minus 22, which is -46. And the determinant of B is 240 minus 286, which is -46. They're equal to each other. Now, this is probably the most useful because, just like we looked at here, when we have all these zeros, it makes it a lot easier to calculate the determinant. So if we can use our Gaussian elimination techniques to get all these zeros when we have to do this by hand, then we'll be able to more easily calculate the determinant. Now the fourth property that you need to know is that if any one row or column of the matrix is a multiple of the other row, then the determinant is equal to 0. So for example, if we have this matrix here, 2, 6, 1, 3, okay, this column here is a multiple of this one, or they can be multiples of each other. This one is this one times 2, or this one is this one times a half. So that means that the determinant, if this is A, then the determinant of A has to be 0. You can see this, 6 minus 6. Okay, so if you have any one row or column of a matrix is a multiple of the other row, then the determinant is equal to 0. If you can look at even like a 3 by 3, if we have if we look at this 3 by 3, we see that this column and this column are multiples of each other, so the determinant is going to equal 0. You don't have to calculate it out because you know already. All right, the last property we're going to talk about is if the matrix is in echelon form, and remember that echelon form means that all the entries below the main diagonal are 0. So if it's in echelon form, then the determinant is the product of the main diagonal entries. So if we have A is in echelon form, so we've got zeros all below our main diagonal, then the determinant is just 7 times 1 times 2, 14. So if you got it in echelon form, again, you can use all those Gaussian elimination techniques to get there so that you can have it in echelon form, and then you'll be able to have the determinant much easier. So those are the 5 properties. You need to be familiar enough with them to recognize when you can use them as a shortcut and be able to find those determinants. Like I said, a 2 by 2 you must be able to do by hand. A 3 by 3 you need to be able to do by hand. But bigger than that, we'll look at doing them by hand. We'll do a few by hand in class. But for the most part, I just want you to know the techniques so that you know if your calculator is giving you a right answer or not. So make sure that you've read this section thoroughly, looked over the examples in the book, and we will talk about this some more in class.